So for our first sample problem on growth and decay class, you are given a chemical reaction. So suppose that a chemical reaction proceeds according to the law of growth and decay, and that is the rate of decrease and the consumption of the substance is directly proportional to the amount present. So if you're going to understand properly the phrase, the rate of decrease in the consumption of the substance being directly proportional to the amount present, that is the same as decay. So the rate in which the amount of any substance is decreasing is directly proportional to the amount present. So that's a decay problem. Now, in this particular chemical reaction, we do not know the species. We do not know the chemicals. We do not know the materials that are contacting. All we know is that the manner of decrease is modeled using the decay model. Now, if half the substance A here, whose identity is not specified, has been converted at the end of 10 seconds, find when 9/10 of the substance will have been converted. So I place the answer here, which is 33 seconds. We are to determine how long will it take for 9/10 of the substance to be converted. So in solving this problem, of course, in any problem on growth and decay, you need to start with what the problem provides you. So I will stop share for now in here. And I'll go to my Jamboard. So in this case, we have to start with what the problem gives us. So the problem gives us a chemical reaction. So we start with the given. So your given is that the rate of decrease in A, and that's in terms of the derivative of A being the amount per unit time, is directly proportional to the amount present. But since the problem is saying there is a decrease in the amount of A because it is being consumed in the formation of the product, then we will have a negative in this side. So this is the statement wherein we're going to base the principle of decay in the first statement of the problem. What else is given in the problem, if I will go back to that, is that it says here that half of the substance have been converted in 10 seconds. So I'll go to the part. Yes?
Miss, yung board mo, miss.
Yes? What about the board?
Miss, hindi naman makita.
Oh, wait. Okay, I'll go back to sharing. Sorry. Do you see the board now?
Yes, miss. Thank you.
Okay. So this is your given. The rate of decrease in the amount of A is directly proportional to the amount of A present at any time. And it's a negative because this A is decreasing. So if this is increasing, this should be positive. So you need not write a negative sign here. This is based upon the first statement of the problem wherein we are allowed to use the decay principle in this particular chemical reaction. Now, I will just read what we have there, so I will not keep on sharing. So it says in the second statement that half of the substance A has been converted at the end of 10 seconds. Half of the substance have been converted at the end of 10 seconds. So you can write here T is equal to 10 seconds. And we can say that when half of A has been converted, then the amount of A after 10 seconds would be 0.5 of what we have originally. So half of the substance have been converted after 10 seconds. So this is a condition that is given in the problem, meaning the amount of A after 10 seconds is 0.5 of A sub O, where A sub O is the initial amount. So that's the second statement in the problem. Then it says that you are to find when will it that 9/10 of the substance will have been converted. In this case, we will now be going to the required information in the problem. So in terms of required, you are to determine the time when, so what's that? 1/10 of the substance have been converted. If 1/10 of the substance have been converted, how much is left then? How much is A? In this case, if 1/10 has been converted. Anyone? If 1/10 has been converted, how much was left after this time that the problem is asking? Anyone? So if 1/10 has been converted, then what remains is just 90% because 10% was already converted. So what you have after this time, which you are to find out, is only 90% of the initial. Now we go to the solution of this problem. And I said, whenever you solve problems in DE, you need not derive the equation. So I'll go directly to the equation for decay. And that's A equal to A sub O E raised to negative KT. Okay? So this is our formula. This formula was derived from this one. I need not derive it again. So I'd like to use this particular condition. That way, I will be able to determine the decay rate constant K. So the purpose of this initial condition is for you to determine the decay rate constant K. So I will now substitute that after 10 seconds, your A is 0.5, A sub O. And this would be A sub O. And you have E raised to negative K. And then your time here is 10 seconds. If you notice, you can cancel the A sub O. And you have the 0.5 here being equal to E raised to negative 10K. Now, in the process, I'm sure you know what to do. You will need to get the ln of 0.5 on the left side and equate that. So if this one is ln already, this would be negative 10K. So now you will have an answer for the K. Can somebody give me the answer for the K? What's the answer for the K in this case?
Zero point zero 0.069, miss.
0.069. So your unit for the K is per unit time, by the way. So that's per second. So that's your K already. Now, your original formula, this is your original formula, now has this specific form. So A is equal to A sub O E raised to negative 0.069 T. So that would be the formula that we'll be using so we can determine the T here. Go to the next part. So remember that I'm looking for the time when 90% only of the initial amount is present because 1/10 has already been consumed or converted. So we'll go to the next. So in that case, I will have here 0.90 is equal to this should be AO. This should be AO, E raised to negative point. What's that answer a while ago? That was 0.069. So you will have 0.069T. Again, we don't need really to know the initial amount. So the time here should be the answer that was given a while ago. So the time is
1.52.
Again,
1.52, miss.
or is it 1.52? Let's go back to the problem. Is it correct? Says here, oh, 9/10. Sorry, class. 9/10 would have been converted. I read it wrongly. I said 1/10. If 9/10 have been converted, then it should have been 1/10. So I'll go back to the previous. We'll change this one. If 9/10 has been converted, then this should be, what is left is only 0.10. I read it wrongly. So that should be here 0.10. This should be 0.10. And in here, we should have 0.10. So this should be point, because 9/10, so this is 0.10 AO. So that should be 33 now. Is it 33?
33, miss.
Okay, so that's
Yes, miss.
so it's now 33 seconds. So again, I read it wrongly. What is consumed is 9/10. So if 9/10 is consumed, what is left is 10% only, and that's 1/10. So that should be what is written here on the required. Okay, any question for this problem? So you're able to determine how long will 90% would have been converted, meaning the remaining amount of A this time is only 10%. If there's no question, I'll go to the second. Okay, no question. Then I will transfer to a different screen. Okay, so do you see the sample problem again?
Yes, miss.
Okay, so number 2 talks about money being saved in the bank. But this is now, this is not, by the way, how the bank computes for our interest, for our money. This is just a pure application of the principle of growth as applied to money that was kept in a bank. But this is not how the bank actually computes for our money after a year or after some time. So it's stipulated here that the manner of your money being having interest in the bank is compounded continuously. So I will explain. So for second problem, a bank offers 5% interest compounded continuously in a savings account. Now, whenever a problem concerning with money or anything that was placed on, let's say, a principal that was placed to earn interest, if the phrase that was used in the problem is compounded continuously, you can treat it as a growth problem. So meaning you can apply the principle of growth problem in DE. But if the problem says compounded annually, compounded semi-annually, compounded quarterly, you cannot anymore apply the principle of growth. Only when the phrase is limited to compounded continuously. Now, this 5% class, what is good about this kind of problem is the interest rate that is given is already the growth rate constant K. In this case, there's no need for us to determine the K in our problem because the interest rate is already the K. It is already the growth rate constant. So we don't need to determine it. So directly, we are just asked to determine the amount earned in 1 year on a deposit amounting to 100 peso. So we are asked for the amount. And then letter B, what should be the equivalent rate if the compounding were done annually? To take note, the question here is asking what is the true interest rate, and that is the equivalent rate if the manner of compounding the interest together with the principal is done once a year. That's this is what it means. We're done annually. So we'll first go to the treatment of the first required information, which is an example of a growth problem. So take note of that. I will again change what I'm sharing here. Then I'll go to my board. Okay, so we go to this sample problem number 2. So for number 2, you're given is only one thing, and that's your K. Your growth rate constant for your money is 5%. So that would be 0.05. And this is per year, because the compounding continuously, and we're going to compute for the corresponding amount after a year, is on a yearly basis. So K is equal to 0.05 per year. Then for the required information, so for letter A, you are asked for the amount. So let's say the amount is P at T equal to 1 year. Let me check if it's 1 year. Probably I forgot. So for determine the amount earned in 1 year. Okay, so that would be 1 year. So that's it. The principal after 1 year. The letter B, the true interest rate, or the equivalent interest rate if the manner of compounding is annually. This one is compounded continuously, but still you are putting the time here as on a yearly basis. Now we go to the solution. So for letter A, we'll go directly to the formula that we can use. So A is equal to AO e raised to KT. So take note, this is already positive because this is a growth problem. Our money is expected to grow over some time. By the way, we are to assume that we did not withdraw from the 100 peso that was placed into the account. And another assumption is that the rate is constant for the entire period in which we are accounting for the principal, and that is 1 year. Now in here, we're going to place in already the amount, which is 100. That's the initial amount placed in the deposit. We have E, and you have K is 0.05, and for the time, which is 1 year. And automatically, in this case, you get to know the value of the principal after a year. In that case, the value is
105.13.
100. So your money is 105.13. This is after a year. But if we go back to the question class, I'll just read it to you. It says the amount earned. So what we have solved actually is the amount after a year. So our earning, so actually it's, if it's the earned amount, I'll just erase this again. If it's the earned amount, and if we will place interest as capital letter I, then we're after the interest that our money earned. So we are after the interest. Okay? So now I will find the interest. So interest will simply be the difference with your money now than what it was before. So the interest or the earned amount is 5 pesos and 13 centavos in a year. Now if you go to letter B, and it's asking for the actual interest rate, that should be the earned interest over the initial amount, and that's the P sub O or the A sub O times 100. So the earned interest that you have here, this is the one that you earned. This is the amount that your money earned, your 100 peso. So place it here. Your initial amount placed in the deposit is 100 times 100. So the equivalent rate is 5.13%. So you're getting the equivalent rate, annual rate, that is based only on the interest, not on the actual amount after the period. And that's the 105.13. So this is in the case of number 2. Any question with number 2? Okay, so your silence means that you fully understand what we're doing in the second sample problem. So we go to the third. I'll stop share and I go back to my screen. Where was that? Okay, so we have this last problem, determining the population of the city. So again, when we speak of population, it's very seldom and unlikely that the population will decrease over time. So this is a case of growth again. So the population of a certain city is known to grow at a rate proportional to the number of people presently living in the city. Again, this particular phrase tells you that you are allowed to use the principle of growth. Now, in this city, if after 10 years the population tripled, and after 20 years the population became 150,000, find the number of people initially living in the city. So in this case, you're not given the initial value of the people in the city. Only that after 10 years, the value tripled, and after 20 years, the population became 150,000. You are to determine the number of people in the city, initial that is, the initial amount of people living in the city. So again, for this problem, you'll start with the given. So for the city, it says that after 10 years, the population, if we will represent it as A, tripled. So in algebra, then it would be 3 times of the initial. Okay, it tripled. Then next is after 20 years, the population is 150,000. These are conditions given in the problem. Now the problem is asking you to determine the initial population A sub O. Okay, so you're given, if compared to the first two sample problems in here, the difference is you were given two conditions. Now, so we go now to the equation that you can use. So since it's, okay, I'm given 10 minutes. Okay, where was I? I was cut. So I'll go back here. Okay, class, wait, huh?